Hello everybody, welcome into another lesson. So today we are going to talk about writing equations of lines. And here I have a form that some of you may or may not be familiar with that we talked about in Algebra 1. This is the point slope form of a line, for the linear equation of a line. This is given as y minus your y coordinate equal to your slope m times the quantity of x minus your x coordinate. This form is useful for if you know the slope of a line and one point it goes through. And if you know only one point it goes through, you can use that and the slope to find the equation of a line, which will end up actually, once you find your equation of the line, this will convert from point slope form into slope-intercept form. So let me show you how that works. Alright, so let's see. We're going to do 3 exercises here to start with, then we'll do some more. Find the equation of a line with slope 5 passing through the point 1, 2. Alright, so we're being asked to find the equation of a line that has a slope of 5. So the slope of the line is 5 and it passes through the point 1, 2. So we only know the slope and then one point the line passes through. That's okay. What we can do then, take the point slope form of the formula, which would be y minus your y coordinate of that point it passes through of 2. You set that equal to your slope of 5 times the quantity of x minus the x coordinate of the point it passes through, which would be 1. So you start out with the equation in point slope form of y minus 2 equals 5 times the quantity of x minus 1. Then you just do your distributive property. You would get y minus 2 equals 5x minus 5. And then you just want to get the y by itself. So add 2 to both sides. You would get y equals 5x minus 3. And that would be the equation we're looking for. So the equation of the line that has slope 5 and passes through the point 1, 2 is y equals 5x minus 3. And I got a couple more examples of problems like this, then we're going to do some other problems. Alright, so let's see. This time we have a slope of -4 passing through the point 3, 8. So we are being asked this time to find the equation of a line that has a slope of -4 and passes through the point 3, 8. So again, start with your point slope form, which would be y minus the y coordinate of the point it passes through, which is 8. Set that equal to your slope m, which is -4, times the quantity of x minus the x coordinate of the point it passes through, which is 3. Okay, so you start with y minus 8 equals -4x minus 3. So then now do your distributive property on the right hand side. You would get y minus 8 equals -4x plus 12. And then, of course, add 8 to both sides to get y by itself. You get the equation of the line being y equals -4x plus 20. So the equation of the line that we're looking for with a slope of -4 and passing through the point 38 is y equals -4x plus 20. I got one more problem just like this. All right. Let's see what we get here. This time we're given a slope of -2/5 passing through the point -10, 3. So we need to find the equation of a line with the slope of -2/5 passing through the point -10, 3. So start out with y minus the value of the y-coordinate of the point it passes through, which would be 3, equal to your slope of -2/5 times x minus the x-coordinate of the point it passes through. So that'd be minus 10, which would turn into y minus 3 equals -2/5 times the quantity of x. Then you have minus 10. This would turn into x plus 10 for that quantity. So then do the distributive property on the right. You'll get y minus 3 equals -2/5 x. Now what is -2/5 times 10? That'd be -4. So then you have y minus 3 equals -2/5 x minus 4. Add 3 to both sides to get y by itself. You would get y equals -2/5 x minus 1. So the equation of the line we're looking for with the slope of -2/5 passing through the point -10, 3 would be y equals -2/5 x minus 1. Okay, now we're going to move on to some slightly different exercises. Okay, so a little bit different here. We need to find the equation of a line passing through the points 1, 1, and 4, 7. We don't know the slope this time, but we are given 2 points that the line passes through. Whenever you're given 2 points that the line passes through, do yourself a favor and find the slope first. Always start out by finding the slope. If we remember, the slope is your second y-coordinate, which in this case would be 7, minus your first y-coordinate, which is 1, all over your second x-coordinate, which is 4, minus your first x-coordinate, which is also 1. Well, 7 minus 1 is what? That's 6, over 4 minus 1, which is 3. So that's going to give you a slope of 2. So we found the slope of the line now. Now how are we going to find the equation? Well, what you have to do is just pick one of these points and use those as your x1 and y1 values. I'll demonstrate with both of them. Whichever point you go with, once you know the slope, it doesn't matter. You'll get the same result in the end. I'll prove it to you. So let's start out with y, then minus your y1 coordinate we'll call 1, would be equal to your slope of 2 times x minus your x coordinate of 1, which would give you y minus 1 equals 2x minus 2, which would then give you that y equals 2x minus 1. Alright, and then let's prove it with the other point. So we'll do y minus 7 equals 2 times the quantity of x minus 4, which would end up giving you y minus 7 equals 2x minus 8, which would also give you y equals 2x minus 1. So this proves what I'm saying, that once you know the slope of the line that passes through 2 points, pick either point and you'll get the same result no matter which one you go with for your point slope form. So the equation of the line passing through the points 1, 1 and 4, 7 is y equals 2x minus 1. That's what you should get. Alright. The rest of these I'll only pick 1 point, but I just wanted to prove you could do it with either one. It wouldn't matter. So I just wanted to prove that to you all. Alright, what points do they give us this time? -1, -3, and 2, 1. Alright, so we need to find the equation of a line passing through the points -1, -3, and 2, 1. So again, we're just given 2 points. We don't know the slope yet. Well, let's find the slope first. So the slope, of course, is equal to your second y-coordinate, which would be 1, minus your first y-coordinate of -3, all over your second x-coordinate of 2, minus your first x-coordinate, which would be -1. So you have 1 minus -3 over 2 minus -1. That's going to turn into 1 plus 3 all over 2 plus 1, which would end up giving you a slope of 4/3. So now we found the slope of the line going through these 2 points to be 4/3. Now all we need to do is just put everything into point slope form, get the equation of a line. So take your pick of whichever point you'd like to work with for that. It won't matter. I'm going to pick the point 2, 1. So we'll do y minus 1 for the y-coordinate equals that slope of 4/3 times the quantity of x minus your x-coordinate of 2. So then you would end up with y minus 1 equals 4/3 x minus 8/3. Then you would have y equals 4/3 x minus 8/3 plus 1. Well, what's -8/3 plus 1? 1 is also the same as 3/3, is it not? In the end, you should get your equation being y equals 4/3 x minus 5/3. So the equation of the line passing through the points -1, -3, and 2, 1 should be y equals 4/3 x minus 5/3. Alright, let's see here. This next one has the points -3, 1 and 3, 3. Okay, so we need to find the equation of a line going through the points -3, 1 and 3, 3. So since we just know 2 points, let's find the slope to begin with. So the slope equals your second y-coordinate of 3 minus your first y-coordinate of 1 over your second x-coordinate of 3 minus your first x-coordinate of -3. So you have 3 minus 1 over 3 minus negative 3. This will turn into 3 minus 1 over 3 plus 3, which would end up giving you 2/6, which reduces to 1/3. So now we found the slope of this line to be 1/3. Let me check something real quick here. I'm just making sure I don't have any crises in my life. Looks like we're good. So the slope of this line going through these 2 points is 1/3. Now, all we need to do is pick whichever point we'd like to work with for our point slope form of the line. I'm going to pick 3, 3. So we'll take y minus the y coordinate of 3 equal to our slope of 1/3 times x minus the x coordinate of the point we're working with, which would be 3. So then we do our distributive property. You'll have y minus 3 equals 1/3 x minus 1, which would end up in the end giving you y equals 1/3 x plus 2. So the equation of the line going through the points negative 3, 1 and 3, 3 would be y equals 1/3 x plus 2. Alright, one more exercise like this, then I have some different ones again. This time we have the line through the points negative 2, negative 1, and negative 6, negative 5. So we're being asked this time to find the equation of the line passing through the points negative 2, negative 1, and negative 6, negative 5. So let's start out finding our slope. So we'll take the second y coordinate of negative 5 minus your first y coordinate of negative 1 over your second x coordinate of negative 6 minus your first x coordinate of negative 2. So let's see, negative 5 minus negative 1 turns into negative 5 plus 1 over negative 6 minus negative 2 just turns into negative 6 plus 2, which would then equal, of course, negative 4 over negative 4, which would just give you a slope of 1. So the slope of this line is 1. Now that we know that, let's put this into point slope form. Pick your favorite point you want to work with. I'll go with the point negative 2, negative 1. So we'll take y minus the y coordinate of the point of negative 1, set that equal to our slope of 1, times x minus the x coordinate of the point, so that'd be x minus minus 2. Well, y minus minus 1 turns into y plus 1. Well, if you have a 1 outside the parentheses, you don't even have to worry about it. It's just going to be whatever inside the parentheses. So y plus 1 would equal x minus minus 2. That'd be x plus 2. Which then now, let's solve for y. You would get y equals x plus 1. So the equation of the line through the points negative 2, negative 1, and negative 6, negative 5 would be y equals x plus 1. Alright, now we change it up again a little bit. You'll see just how it does here in a second. Alright. Okay, so this time we're asked to find the equation of a vertical line through the point 2, -5. So find the equation of a vertical line through the point 2, -5. Well, if we remember, a vertical line just stands straight up. Anyone remember the acronym VUX-HOI? Who remembers VUX-HOI? That's going to help us here, particularly for this exercise and the next one, the VUX part. So vertical line, that's the V. It's a vertical line, which means it has an undefined slope. A vertical line has an undefined slope. So vertical line, undefined slope, x equals. X equals would be the equation of the line. If you have a line going through a point that's a vertical line, all you're going to do is set the x equal to the x coordinate of the point that it passes through. You would just get x equals 2. That's all you would get, x equals 2 for the equation of the line. Because if you were to graph this point 2, -5 in the coordinate plane, draw a vertical line going through it, it's going to go through 2, -6, 2, -7, 2, -8, 2, -4, 2, -3, 2, 0, 2, 5, to infinity. But it's going to pass through the point x equals 2. So that's how this VUX thing works. Vertical line, undefined slope, x equals. And if it's an x equals 1, just set the x equal to the x coordinate of the point it passes through. So really quite simple for that, actually. Alright, we're going to find the equation of another vertical line, this time passing through the point 3, 1. So we have a vertical line that passes through the point 3, 1. Well, again, a vertical line, undefined slope, x equals. So you'll just take your x, set it equal to the x coordinate of the point it passes through. You would get x equals 3 for the equation of the line. It's really that simple with vertical lines. Alright, now let's change it a little bit here. Wrong color for this. Hold on. Alright, so this time we're being asked to find the equation of a horizontal line through the point 2, -5. So find the equation of a horizontal line through the point 2, -5. So if it's horizontal, it lays straight down. So you have the HOI part, H for horizontal line. The O is for 0 slope. And if you think about a line that lays straight down, if you could just walk straight across it without having to climb at all, if you're just walking straight across a flat surface, it has no slope. So horizontal line, 0 slope, y equals. You'll get the equation of the line to just be y equals the number. So if it's a horizontal line going through the point, you'll just take y equals the y coordinate of the point it passes through. The equation of this particular line would be y equals -5. And if you were to graph y equals -5, it definitely passes through 2, -5. It would also pass through 3, -5, 4, -5, 1, -5, 0, -5, -5, -5, and so on. It would just be a horizontal line with y equals -5 as your equation. One more simple horizontal line, then we'll get into a little bit different problems. So we are going to find the equation of a horizontal line through the point 3, 1. So again, you have your HOI, horizontal line, 0 slope, y equals. So you just take y, set it equal to the y-coordinate of the point it passes through, which would be 1. So the equation of the horizontal line through the point 3, 1 is just y equals 1. That's all that would be. All right. I think we're ready to move on to some other exercises here. Now this is where it really gets interesting. Okay. So, we're being asked to find the equation of a line through the point 5, -3 and parallel to the line x equals 4. Okay, so we need to find the equation of a line through the point 5, -3 and parallel to the line x equals 4. Well, this is again where Vux-Hoy comes in handy. If you just have x equals 4, that means it's a vertical line going through 4, 0 on the x-axis and continuing straight down infinitely, straight up and down infinitely. Which means the slope is undefined. Okay? So the slope, we'll label this M1. If it's through the line x equals 4, that means the slope is undefined. Now, if we want to find the slope of the line through the point 5, -3 that is parallel to x equals 4, if two lines are parallel, what is true about their slopes? That they equal each other. That means that the slope of the second line also would have to be undefined in order for these lines to be parallel, otherwise they would intersect. Okay, so if these lines are now, if both slopes are undefined, that means they're definitely parallel, and then you would define the equation of the second line. If you have an undefined slope, part of the Vux thing is vertical line, undefined slope x equals, it's going to be another vertical line through x equals the x coordinate of the point the line passes through, which would be -3. So the equation would simply be x equals -3 for the other line, for the line that's parallel to x equals 4 passing through the point 5, -3. All right. Actually, let's keep this one. Alright, we're going to switch it up a bit again here. We want to find the equation of a line passing through the point 5, -3 again, and parallel to the line y equals 4. Okay? So we know the line passes through the point 5, -3. The line is parallel to the line y equals 4. Well, let's take the slope of the first line here, y equals 4. Remember Hoy. Horizontal line, 0 slope, y equals. You just have y equals 4. Which means you have a horizontal line with a slope of 0. So the slope of the first line through y equals 4 is 0. If you're going to have a parallel line to this line, that means the slope of the second line has to be the exact same as the slope of the first line. So that means the second slope through the line passing through 5, -3 would also have to be 0 if that's the case. Now, let's go to the equation of the line. Again, you have a 0 slope. That's part of Hoy. Horizontal line, 0 slope, y equals. So you would end up with a point y, you would end up with y equals -3. You know, my last exercise should be x equals 5. I'm sorry about that, folks. It dawned on me I put the y coordinate in for the x coordinate. So the last equation we did in parallel to the line x equals 4 should have been x equals 5. My bad, but I wish to clarify that now. But anyway, you would get the equation y equals -3 that would be parallel to y equals 4. Let's do another one here, sort of similar. All right, -8, -2. Alright, so we are being asked to find the equation of a line through the point -8, -2, and parallel to the line x equals 5. So it's a similar problem. Start by finding the slope of your first line of x equals 5. Alright, if it's x equals, that means it's a vertical line with an undefined slope. So the slope of the first line is undefined. Now, if two lines are to be parallel, that means they have to have the same slope. So that means the slope of the second line should also be undefined, which would give you two vertical lines that are parallel to each other. So this is part of Vux. If it's x equals, you have a vertical line, undefined slope. So now we're just going to take x, set it equal to the x coordinate of the point this passes through, which would be -8. So you would get the equation x equals -8 for that line that passes through the point -8, -2, and is parallel to x equals 5. And if you graph these two lines, you would find they are in fact parallel to each other. Okay, what if this time we're asked to find the equation of a line through the point -8, -2, and parallel to the line y equals 5. So it's a similar problem, only this time it's parallel to the line y equals 5. Well, what's the slope of that first line of y equals 5? If it's y equals horizontal line, right? You picture the line y equals 5, it's a horizontal line. So you have horizontal line, y equals 0 slope. So the slope of that first line is 0. If the two lines are to be parallel to each other, that means the slope of the line passing through -8, -2 also needs to be 0 in order for them to be parallel. So now that we know the slope to be 0, we're going to have a horizontal line since y equals. Now we just take y, set it equal to the y coordinate of the point it passes through, which would be -2. So you would get the equation of that line to be y equals -2. And if you graph y equals -2 and y equals 5, they would be parallel to each other. Two parallel horizontal lines. All right. A little bit different here. I have, let's see, 1, 2, 3, 4, 5, 6 more. I got 6 more exercises. Alright, so a little bit different here. We are being asked to find the equation of a line through the point 5, 7 and parallel to the line y equals 3x minus 4. So it's a little bit different. Find the equation of a line through the point 5, 7 and parallel to the line y equals 3x minus 4. Well, like we did with the other problems, go ahead and take the slope of your first line of the y equals 3x minus 4. What is the slope of that first line? It's going to be 3, right? Because it's in the form y equals mx plus b. So the first slope is 3. Now, if we want to find the equation of the line that goes through the point 5, 7 and is parallel to the line y equals 3x minus 4, that means in order for the line to be parallel, the second slope also has to be 3. They have to have the same slope for them to be parallel. So that means the slope of the line parallel to y equals 3x minus 4 going through the point 5, 7 also needs to be 3. Now that we know the slope of that line, let's put this into into point slope form. So take your y minus the y coordinate of the point it passes through, which would be 7. That's going to be equal to your slope of 3 times x minus the x coordinate of the point it passes through, 5. So you would end up getting y minus 7 equals 3x minus 15, which would end up giving you y equals 3x minus 8. So the equation of the line that passes through the point 5, 7 and parallel to the line y equals 3x minus 4 would be y equals 3x minus 8. And if you graph them, two lines, they would in fact be parallel to each other. Oh, good one. Good one. All right. So, this time we are being asked to find the equation of a line through the point negative 1, 3 in parallel to the line 3x plus 5y equals 15. So they actually gave us the equation of the first line that already exists to be in standard form. And instead of slope-intercept form, it's in standard form. So we have 3x plus 5y equals 15. Why don't we go ahead and work on converting that to slope-intercept form, all right? So in order to convert that 3x plus 5y equals 15 from standard form into slope-intercept form, what do we need to do? Get the y term by itself. So that would give you 5y equals negative 3x plus 15, which now we just solve for y. That would give you y equals negative 3/5 x plus 3. So now we have the slope of this line here. We got this into slope-intercept form. The slope of this first line would in fact be negative 3/5, right? So we found the slope of this line to be negative 3/5. So now we need to find the slope of the line through the point negative 1, 3 and parallel to this line. So if it's going to be parallel to that line, that means the slope of the next line going through negative 1, 3 should also be equal to this slope and be 3/5. So the slope of the second line should also be negative 3/5 in order for it to be parallel. Now that we know the slope of the line that's passing through the point negative 1, 3, we need to actually do the equation in point slope form. So you would take y minus your y coordinate of 3, set that equal to negative 3/5, which is your slope, times x minus the x coordinate of the point x minus minus 1, which would turn into y minus 3 equals negative 3/5 x, 3/5 times x plus 1, which would end up giving you y minus 3 equals negative 3/5 x minus 3/5. Well, let's add 3 to both sides to solve for y. So you would end up getting y is equal to, all right, what's negative 3/5 plus 3? Well, 3 is also 15/5, right? 3 is 15/5, so if you add 15/5 to negative 3/5, you would get 12/5. So y would equal negative 3/5 x plus 12/5. So the equation of the line passing through the point negative 1, 3 and parallel to the line 3x plus 5y equals 15 will give you y equals negative 3/5 x plus 12/5. And if you were asked to convert this into standard form, you could do that, or you could just leave it in slope-intercept form. Either way, depends on what your teacher wants. Follow what they say, but okay. 4 more problems. We're going to change it a little bit yet again. Let's move this over some here. Okay, so this time we're being asked to find the equation of a line through the point negative 3, negative 2 and perpendicular to the line 8x minus 5y equals 0. So now they want us to find the equation of a line through a point and perpendicular to a given line. Well, we'll start this the same way. We're going to find the slope of the first line of 8x minus 5y equals 0, right? Because this equation is in standard form, we want to convert this to slope-intercept form. So get the y term by itself on one side, that would give you 5y equals 8x. Then you just solve for y, you would get y equals 8/5 x. So y would equal 8/5 x, which means the slope of this line would end up being 8/5, right? So the slope of this first given line is in fact 8/5. Now, if you want to find a line perpendicular to this line, what is true for a perpendicular line with slope? It's the negative reciprocal of the other slope. What is the negative reciprocal of 8/5? That would be negative 5/8. So that means the slope of the line you're trying to find would in fact be negative 5/8, since you want the negative reciprocal of the first slope. Now that you found the slope of the second line, you're just going to put this into point slope form. So take y minus the y coordinate of the point you're trying to go through, so it'd be y minus negative 2 equals negative 5/8 times the quantity of x minus the x coordinate of the point it passes through, minus 3. So this would turn into y plus 2 equals negative 5/8 times the quantity of x plus 3. So then you would end up having y plus 2 equals negative 5/8 x minus 15/8. Now we just subtract 2 from both sides. Well, what is 2 in terms of a denominator of 8? It would be 16/8, right? 2 is 16/8. So if you subtract 16/8 from this, you would end up with the equation y equals negative 5/8 x minus 31/8. So the equation in slope-intercept form of the line through the point negative 3, negative 2, and perpendicular to the line 8x minus 5y equals 0 would be y equals negative 5/8 x minus 31/8. And if your teacher wanted you to, convert it into standard form, but I'm just going to leave it in slope-intercept form for now. All right, 3 more exercises, folks. We're almost there. Alright, so we need to find the equation of a line through the point 8, 0 and perpendicular to the line 3x plus 4y equals 12. So again, start out with your first line at 3x plus 4y equals 12. It starts again in standard form. We need to convert it into slope-intercept form to be able to find the slope of the line. So if you do that, get the y term by itself, you would get 4y equals negative 3x plus 12, which would just give you y equals negative 3/4 x plus 3. So the equation of this line here in slope-intercept form would be y equals negative 3/4 x plus 3. So what's the slope of this first line? That's going to be negative 3/4, right? If you want to find the equation of a line perpendicular to this line, what's true about the slope of the other line? It has to be the negative reciprocal of this slope. So the negative reciprocal of negative 3/4 would be positive 4/3. So the slope of the line we're trying to find should be positive 4/3. Now, since we know the slope, we can use the point slope form and solve for the equation of the line. So take y minus the y coordinate of the point this passes through, which would be 0. Set that equal to 4/3, that slope, times the quantity of x minus the x coordinate of the point it passes through, which would be 8. Well, y minus 0 is just y. That'd be equal to 4/3 x minus 32/3. And if you were asked to convert this into standard form, you could do that, but I'm just leaving it in slope-intercept form. You get y equals 4/3 x minus 32/3. All right, 2 more problems. These last 2 will really test us a bit. Alright, so these last two problems are going to be like this. We need to find the equation of the perpendicular bisector of the segment joining 0, 0, and 10, 6. So let me read that again real quick. Find the equation of the perpendicular bisector of the segment joining 0, 0, and 10, 6. Okay. First thing I would do, ignore the perpendicular bisector for a minute. Let's focus on the segment joining 0, 0, and 10, 6. First thing I would do, if you have 2 points, find your slope, right? So find the slope of those, of the line going through these 2 points. So we'll call that M1 your first slope. That's going to be equal to your y2 coordinate of 6 minus your y1 coordinate of 0 over the x2 coordinate of 10 minus the x1 coordinate of 0, which would give you 6 over 10, which means the slope of the line of the first line would be 3/5. Alright, so that's very good. We found the slope of the line segment joining 0, 0, and 10, 6. It turned out to be 3/5. Now, what does a perpendicular bisector do to a line? Since we're trying to find the equation of that line, what does a perpendicular bisector do to a line? It's definitely perpendicular to the line, and it bisects the line based on the definition of perpendicular bisector from earlier in the course. If a line is bisected, that means the perpendicular bisector of the line is perpendicular to that line at the midpoint of the line. So we also need to find the midpoint of the line. If we remember the equation of the midpoint, it's going to be your x1 coordinate of 0 plus your x2 coordinate of 10, all that divided by 2, and then your y1 coordinate of 0 plus your y2 coordinate of 6, all that divided by 2, which would give you, of course, 10 over 2, and then 6 over 2, giving you the midpoint of this segment here would end up being 5/3. So we have now found the midpoint of this segment here joining 0, 0, and 10, 6 to be 5/3. Now that we found the slope of the first line, and we found the coordinate of the midpoint of that segment where the perpendicular bisector meets the line, what we need to do now, first find the slope of the perpendicular line to the segment. The perpendicular line would have to have a slope that's the negative reciprocal of this segment. The negative reciprocal of 3/5 would be what? Negative 5/3. So the slope of the perpendicular bisector should be negative 5/3. Alright? Now, we know the slope of the perpendicular bisector, and it passes through the point 5/3, right? At the midpoint of that segment, we can do point slope form and find the equation of the line. So take y minus the coordinate of the midpoint of that segment, the y coordinate, you would do y minus 3 equals that slope of negative 5/3 times x minus the x coordinate of the midpoint, which would be 5. So you'll end up with y minus 3 equals negative 5/3 x minus 25/3. Okay, now of course we need to solve for y, which means you got to add 3 to both sides. Well, if you add 3, that's the same as adding 9/3 to this, right? If you add 9/3 to negative 25/3, you would get negative 16/3. So y would equal negative 5/3 x minus 16/3. And ladies and gentlemen, that is the equation of the perpendicular bisector of the segment joining 0, 0, and 10, 6. Is y equals negative 5/3 x minus 16/3. And I got one more problem for the day, and it's just like this one. One more example of this. All right. Okay, so this time we're being asked to find the equation of the perpendicular bisector of the segment joining negative 3, 7 and 5, 1. So we have an identical problem just with different coordinates. First thing you want to do, forget the perpendicular bisector for a minute, just find the slope of the line going through negative 3, 7 and 5, 1. So we'll do that here. The slope equals that y2 of 1 minus your y1 of 7 over your x2 of 5 minus your x1 of negative 3. So this would become 1 minus 7 over 5 plus 3, which would give you negative 6 over 8, which would give you the slope of that line segment joining those 2 points to be negative 3/4. So the slope of the line segment joining negative 3, 7 and 5, 1 is negative 3/4. Okay? Now, again, think about what does a perpendicular bisector do to a line based on the definition? It bisects the line, meaning it meets the point, it meets the line right at its midpoint and is perpendicular to the line. So that means we need to find the midpoint of the line segment joining those 2 points. So let's go ahead and find the midpoint. The midpoint, of course, would equal your first x coordinate of negative 3 plus 5 divided by 2. And then you'll take that 7 plus 1, divide that by 2, which would end up giving you negative 3 plus 5 is positive 2 over 2. And then 7 plus 1, that's 8 over 2. So that means the midpoint of this segment would end up being 1, 4. And that would be where the perpendicular bisector meets that segment at the point 1, 4. Okay, so we know where the perpendicular bisector passes through or meets that line segment, and we know the slope of the first line. If you want to find the slope of the perpendicular bisector, that means the slope would be the negative reciprocal of that line segment. The negative reciprocal of negative 3/4 is going to be positive 4/3. So the slope of the perpendicular bisector would end up being 4/3, positive 4/3 at that. So now that we know the slope of the perpendicular bisector and the point it passes through, 1, 4, let's put this into point slope form and solve it. So y minus 4 equals 4/3 times the quantity of x minus 1. That's in point slope form, which will turn into y minus 4 equals 4/3 x minus 4/3. Okay, so now we want to solve for y. Just add 4 to both sides. So if I'm adding 4 to negative 4/3, that's the same as 12/3, right? 12/3 is in fact 4. So if I add 12/3 to negative 4/3, I would get positive 8/3. So the equation of the perpendicular bisector would be y equals 4/3 x plus 8/3. And that's really it for this lesson. So we have 7 more lessons left in geometry, 2 more in the coordinate geometry unit, and then we do 5 lessons on transformations. So the next lesson will be some coordinate geometry problems, which will prepare us for the lesson after that, which will be coordinate geometry proofs. So I hope everybody has a great night. Take care.